How's it going, everybody? And welcome to another installment of a Tech Support Thursday, because guess what? It's Thursday. So in this video, we're going to be focusing on some questions that we got from YouTube comments. If you guys have questions and things like that, drop them in the comments here, and I will be happy to try to answer them. So last night we were doing our Wednesday whiteboard session, also known as Whiteboard Wednesday. And there was a lot of really good comments that came through, and I wanted to go through some of them. So the one that I wanted to cover first and foremost was this one, which I think is a really good question. And the question is, I recently got my CCNA and got hired as a network specialist. I just do routine port security checks and VLAN stuff. What should someone like me make sure I have down before starting a course like yours, with double question marks? And first of all, it's a really good question, and so I'm gonna heart it because it's a really good question. So the first thing I would say is, if you are working your way towards from CCNA and you're heading up in your certification journey, Encore and RC, whatever the flow is going to look like, my advice to you or anyone else that's in your shoes would be to begin with reading a lot of documentation. And that's going to be something you're going to want to be doing anyway, for the simple fact of the majority of the exams you're going to be taking in the future, a lot of the information that is in the documentation is what's used to build the exam questions. Not everything, but a lot of it. The other thing that I would do is, as you're going through and reading the documentation and getting a much stronger understanding of what's going on in technology-wise, you're definitely going to want to spend a lot of time on the CLI. And the reason why I say that is because you're going to be getting peppered with lots of exhibits, meaning you're going to get show command outputs, configuration snippets, things like that, and you're going to get questions on, based off of the exhibit above, what is true or what is not true, stuff like that. So you're going to have to be able to look at something and be able to determine, based off the answers, you have to look at it and go, could be anything really, right? So you're going to have to look at it and try to interpret what you're seeing, whether it's an EIGRP interface output or a OSPF database. It could be any type of thing that they want you to be familiar with. So these are some things that you're going to need to spend some time on learning and getting a solid understanding of what's going on. So that would be the first thing that I would do. Documentation, and then spending time on the CLI to understand what it is you're looking at operationally. That would be, if I had any bits of advice, that would be the bit of advice I would give you to start out with. Now, somebody asked, what is the point of the workbook that doesn't provide you with in-depth technical breakdown explanations in the book itself? And the answer to that is, the workbook is meant to be a known good configuration for all of the technologies that are listed on the blueprint of that particular exam. So if it's an RC, it's going to be covering two sections. The first half would be deployment, where we will deploy everything and get everything working. So we have the topology fully built out. And then the second half would be systematically breaking it based off of the troubleshooting sections inside the exam blueprint. And the reason why doing that is you'll be able to go through the blueprint and correlate a particular lab to a particular blueprint topic. And you'll be like, oh, that's how that works. So you'll be getting a known good configuration output to get whatever technology it is operational. And then you'll also see how to break it and how to fix it, how to identify it. So that is the goal of what the workbook is for an RC and for Encore. Known good configuration outputs. What do you need to do? What do you need in order to implement a particular service or feature? And then the troubleshooting section is going to be there to help you confirm it's working correctly, And if there is something wrong with it, how do you fix it? Stuff like that. I took the NRC today and failed miserably, ran out of time. I've been there myself. I ran out of time on exams as well. Hopefully the workbook will be beneficial to you. Let's make ICE deployment step by step and make it works for auth. Authentication, authorization, and accounting, or AAA. I'm getting a lot of folks that are saying that, so I guess that's going to be the consensus for real world networking, is we're going to have to implement that. I might even throw it into an RC and Encore just because it's possible, and like, why not, right? So Alec had a couple of questions as well. Some questions and observations regarding your labs. Could you please, this is for the real world, I believe, no, actually, no, this isn't. Could you please use /30 network between network devices in the lab? I see you're using /24. With /30 mask, it will be more real. I noticed that the NRC lab, each distribution switch only has one uplink towards core. Cisco in their documentation advises to use two uplinks, so one to each core switch. Also, you use ring topology in core and in both NRC and real life networking topology. Is there a reason for that? Why not use full mesh? So, couple reasons. It's trying to collapse the sizes of the topology, and whenever I'm doing my documentation of the addressing, it's easier when you don't have crisscross applesauce links. So that is why I did that. So if we take a look at this topology, what he's referring to is why I don't have a crisscross here, and it just makes it easier to populate the links and things like that. So that's the reason for that. Now, there are some other cases in here that we're going to dig into, but for the most part, that's where that piece is going to come into play. I am going to make some adjustments to the topology so that the stuff that we talked about in the live stream about having distribution device or routers going up to firewalls and going up to your edge devices and things like that, and which way is better, put a router in front of a firewall or put a firewall in front of a router. We'll definitely get into those things in the real world course. Another comment was, could you please not incorporate SD-WAN into real life networking topology and just create a separate topology for SD-WAN? Honestly, I wanted this course to be more traditional network and not SD-WAN, SD access. It would be great if you create another topology for real life networking with SD-WAN. So one topology would only for traditional network, another one for SD-WAN. Right now, traditional network is more important to me. I know you create this course not only for me, but I just want to express my opinion, and of course, it's up to you and what you want to do. So it's kind of a mixed bag. For every one person that wants SD-WAN, there's going to be another person that doesn't. And I get that. So these are some of the things that I'm working through. And real world networking, it would probably make sense to have SD-WAN in there because it's a reality. And it would just make the lab that much bigger and that much more complicated. But that's the reality of networking for a lot of folks. So I will take your comment under advisement, but here's the reality of it. Whether you use it or not is, if you came to me and said, hey Rob, I have a boatload of money and I want to pay you to build out a topology that is going to help me become a better engineer. Here's everything that I need you to make it out of. So money, and then the information from your environment and all the different things that you want to learn and have a course built around, then yes, I would say that would be a tangible request. But here's the reality. You're not going to do the former. You're not going to pay me a boatload of money. And number two, the goal here is to be real world in all aspects that I can test out and play around with. So that would include doing SD-WAN. If I could do SDA, I would also do SDA. I think it would be awesome to be able to play around with it. Now, I have DNA Center, and I can, if I think it's, I don't forget what version I have, but if I was to attempt to try to get this to load, I'd have to go through the installation guide and see what the caveats are for it. But part of me is like, yeah, it'd be cool to do it, but beyond that, what's the benefit? So for a wired piece, I'd have to go through the SDA, or I shouldn't say SDA specifically. I'd have to go through the documentation, the design guides, and understand what it is that they would be testing you on inside the Enterprise Infrastructure CCIE. So that's one of those things where I'd have to sit there and figure some stuff out. But at the end of the day, it's always going to be a work in progress, right? So, okay, so a couple clarifying questions about the response that I gave. In another video, you brought another design example. There were 2 edge routers connected to distribution switch and distribution switch connected to Palo Alto. And you said HSRP between Palo and edge router. Please correct me if I'm wrong. There is not any routing protocol between Palo and edge routers, because in case we have HSRP, we don't need routing protocol between devices to fail over. On Palo, there's a static default route configured towards HSRP VIP. How failover handled on edge routers? Maybe some tracking configured on primary router, which tracks some internet IP, and if it's down, then it lowers HSRP priority to primary router. That is pretty much exactly what it did. So you can do what they call half preemption, which means that preempt means to take over. A preemptive takeover, which means you know how it's going to happen before it actually does. So you can have the primary, and then the primary router set up with tracking, and that's exactly what we did. We set up tracking, and then we had it automatically decrement the priority value from the primary router and then fail over to the secondary. But we only did halfway. It would fail from primary to secondary. But we did not have preemption enabled on the other way back, so that if the primary came back online, that it would fail over to the primary from the secondary. So we would fail over, but we wouldn't fail back, if that makes sense. And that was the customer's request. They wanted to make sure, for sure, that the primary circuit was back up, good to go. They could log in, open up a ticket with the provider, all that type of stuff. And I was just like, cool, we can do that. We tested it in a lab, we put the documentation together, and we implemented. It worked out great. So there are ways of making that happen. Again, it's one of those things where it's not best practice, but it's as close to best practice as you can get, but also still meeting the customer's requirements. You mentioned that SPIs on distribution switch should be passive interfaces. So wouldn't it be possible? So it wouldn't be possible to form routing neighborship over LAN-facing interfaces. Cisco also recommends it. But do you remember we discussed if routing neighborship should be working over trunkling between distribution switches, and he said it's a very popular design when the routing protocol neighborship is running over trunkling between distribution switches. But how is it's possible if SPIs will be passive interfaces? Maybe in that case we need to create a separate VLAN, allow it to only between distribution switches, create SPI for that VLAN, and run routing protocol only over this VLAN between distribution switches. In that case, routing can't be formed over LAN-facing interfaces. Is my assumption correct? No. There is a caveat in Nexus VPC when you're dealing with VXLAN that you would use the system infra VLAN to accomplish something very similar to that. But no, that is not the case. So there are two typical ways of handling that. The first way is to do what I mentioned first off, which was to run dynamic routing over the trunk link between the devices. So you're deforming routing adjacency over the interswitch link between your distribution switches via the SPIs. And you would still allow them to propagate routing information and things like that. So there would be no passive interface used. So, which essentially is this design right here. So we have distribution 1, we have distribution 2, we have access 1, we have access 2, and we have links coming down like this, and we have a link going like this. That's in a port channel. There's two ways of doing it. You have your back and forth IGP adjacency set up between the distribution switches riding over the trunk link. And if something were to happen to this port channel, all of a sudden all of your routing protocol adjacencies between distribution 1 and distribution 2 would go down. So normally speaking, you wouldn't actually have this as an alternative path. What you normally would do is on the port channel, you would bump the metric or the cost up so that it is not preferred. And you would have traffic either go this way or this way. And then if one of these links were down, then you would have traffic go this way or this way, depending on the scenario. So that's how you would do it with that. Now, let's assume for the moment that you don't actually have ADJ. Let's first assume for the moment that you don't have a link between them. How does that work then? Can you still run routing adjacencies over this? And the answer to your question is you can. The hellos would go down this way and then back up this way. Actually, that was a bad arrow. You'd send hellos this way, and then they would get propagated back up and vice versa. So would that work? It would, but this is not ideal. You wouldn't want routing protocol hellos going through your access layer switches, because if somebody was to plug in router 1 here to your access layer switch and just happen to have the right information available, they would be able to form a dynamic routing adjacency behind the access layer switch, and you don't ever want that to be the case. So what we do instead to combat that is we will use the passive interface command on the SPI subnets. So we'll say passive interface default, and we'll just know on these links here and this link here, we'll just say no for that particular interface on both distribution 1 and distribution 2, so that you'll form a dynamic routing adjacency with a distribution northbound. You'll still have your interswitch link between the two there, but they wouldn't form any dynamic routing adjacencies over the interswitch link that's the port channel. So it is a best practice to do passive interfaces wherever you can, and Cisco will always recommend that from a security perspective. So, but I also did mention that if you were to do dynamic routing over the interswitch link, that you would have the ability of, if this link went down, to send traffic up to distribution 2, have it flow to distribution 1, and then go outbound. Right? So that is an option as well. So, but the reality of it is, man, that even though best practice is something that you take as far as you need to, it's not the holistic approach. And I've never talked to you in depth on this, but I would assume that you understand what I mean by this. So, typically speaking, when you're starting to get into more complicated designs, is there a wrong way of doing it? No. Are there multiple ways to get the same job done? There is. And that is what the whole point of me bringing that up is. Just because there's 7 different ways to do something, or when you get into more advanced networking, there's 6 ways from Sunday to configure something. That just means there's options to you. And that one option, if you were to implement it, isn't going to make or break what's going on. The key thing here is you take best practice as far as you can until it starts to detract or not be as valuable anymore to getting the customer's requirements met. That is a lot of the reasons why we do stuff in the real world that doesn't make a lot of sense. Or you normally would never do this in a real world or in a best practice case scenario. That's okay. Not every design and every implementation of networking technologies is going to be a best practice design. That's why there's a lot of one-off stuff out there. It's the nature of the beast. So one of the things that I'll do is I'll draw out what this first one was and how we essentially got that to work. So from the top down, we had ISP 1, we had ISP 2, we had Edge 1 and Edge 2. These are routers, and there was a single link to these guys, both their /30s, and just a default route being advertised down. That was it. E1 and E2 were connected to a pair of Cisco switches that were in a stack, like so. And then E1 would connect to switch 1 and E2 would connect to switch 2. And then southbound of that, there were Palos. Palo 1, Palo 2. And these guys would be connected to switch 1, and this guy would be connected to switch 2. And what we did was we ran HSRP between these two routers. So this was our primary, this was our secondary, and we had an IPSLA configured here to ping 8.8.8.8, and so the SLA had a ping that would go out and ping Google. We had a tracking object that would call the SLA, and then we associated that tracking object to to HSRP. And so we went under HSRP and we associated that to the tracking so that this guy right here was set to like a 120, this guy was set to a 100, and we set the decrement to be, I think, what was it, like 30 or something, whatever. It was going to be lower than anybody else. So that's what we ended up doing. Now the Palo still had a default route pointing outbound to the .1 address, and that's what we did, and it worked out great. It didn't matter which box it was going to; it would still get to where it had to go. And there were some optimizations at the switch level. We would do port fast and stuff like that to try to make things converge quicker and things like that. We'd have Nexus 1 and Nexus 2. These were border gateway switches that were wired up like so. The Palos were an HA. So that's essentially the design we ended up deploying and getting working. And it worked out quite well for what we were trying to accomplish. So when you see stuff like this come into play, these guys, there is eBGP here between all these guys, and there's peerings going this way and no peering this way because this guy was, actually take that back. It was peering. We had a peering here and we had a peering here, but no peering between the Palo 2 because it was in standby. Traffic would hit Palo 1 and then it would be pointed towards Edge 1, which would be pointed towards this guy. And everybody was happy. So it would get the job done. So in the event that there was a failure here, let's say that this link went down for whatever reason, the BGP learned default route that would get learned on Edge here would no longer be propagated. And then on top of that, we would no longer be able to ping Quad 8 out this link. So Quad 8 was no longer reachable, and because it was no longer reachable, we dropped from a 120 to a 90 here, and then everything failed over to this guy here, and he took over the HSRP VIP, and so our traffic then shifted from, oops, is that going to work? Nope, that's not what I wanted. Then shifted from Palo here to this guy out going this way. But we would never preempt back. So even if this guy became good again, we would still receive the default route, but the SLA would come back, but we didn't have preemption enabled on this guy to fail back to Edge 1. And that was by design. That's what the customer wanted. So typically, if you were to look at how to do this, you would preempt back, but we didn't do that because that's not what the customer wanted to do. They wanted to make for sure that the main provider was back online before they swung traffic back over. And they would usually do it after hours to not impact user experience and day-to-day operations. So I'm going to put this same design. I'm going to go ahead and clear the screen off into real-world networking. I don't exactly know where I'm going to put it into play here, but it's going to get put into play. And we'll see what that looks like. I might even do some sort of connectivity down here, or I might make the topology a little bit bigger and add in some stuff here. Add some complexity to the network in some respects. But that's essentially what I'm planning on doing, is adding that in as a more advanced design for internet edge redundancy. But the reality of it is, folks, that that's actually a fairly common design. So if you guys have any questions on anything that we're going over, or you're like, this doesn't make sense, let me know down in the comments. I'm happy to try to whiteboard stuff out for you and try to help you understand what's going on and go from there. But I'm trying to keep this video under 30 minutes, and I'm coming up on that time frame now. So I'm going to put all the necessary links in the description. If you haven't already done so, please like, share, subscribe, and I'll catch all of you tomorrow evening, for those of you that are members, on the Friday coaching session. If you're not there or you're not going to be able to make it, that's fine too. But I'll catch all of you guys in the next one.